Hey guys, so I had a friend come to me the other day and was telling me that he was putting a new EFI system on his C10, and he was having trouble because he couldn't seem to get it a constant 12 volt power feed to the ECU when he would take the ignition and go from a run state to a crank state. And he's like, Billy, he said, I can't seem to get this thing to keep constant 12 volts, so what can you do for me? So having been through that situation with my own, I've got a Edelbrock ProFlow 4XT intake system on mine that requires a constant 12 volt as well. I decided that in order to try to keep from having to run from the starter side of the cranking process, with a wire back to my ECU, I kind of wanted a little bit more of a protected circuit and a little bit cleaner circuit. So this is what I come up with. Basically, I use a relay, a diode, and a capacitor. And what I'm basically doing is I'm creating a delay on break circuit so that when I go to the run state with my ignition, I get the 12 volts to my ECU that I need. But when I go from the run to crank, what you have a problem with some ECUs is just that brief lag or that mechanical process when the contacts in that switch are going from run to crank. It drops that 12 volts off and will actually allow your ECU to reset. For example, mine connects through Bluetooth, so it will let the Bluetooth radio disconnect. So I needed to make sure that I had a constant source that went from the run to crank back to run. So by creating this time delay circuit, what it does is it gets the voltage from the run process. There's a capacitor that locks that relay down. It keeps it locked down for a fraction of a second, maybe a second and a half. And then what it does is it allows the crank side of my circuit to come in and continue to power the relay when the capacitor drops off. And then of course once the vehicle starts and you're out of the crank stage and going back to the run, then it lets it go back to the run state with there being no lapse in connectivity. And basically what that does is it protects it from potentially having a no start or a dry start situation where you constantly have it turning over but you can't seem to get it to start, and that's because your ECU has no power. As I show you here in a second with the circuit, I put a diode in place of the crank feed that's going to the relay so that when I go to the run state, I'm not back feeding voltage into my crank circuit, causing my motor to turn over at just the run state. The diode allows the voltage to go one way and not the other. So basically when you look at this, this is my circuit that I've got. If you look, see if I can get something here to kind of point with. As you see, I've got a constant 12 volts. This is what's going to come in right here whenever when the ignition goes to the run state. So I've got 12 volts, energizes my coil, basically lets my contacts close, and then it goes and feeds my ECU. Now mind you, the relay I'm using is just basically one of these little old bad boys right here. I mean, we've all seen them. They're in pretty much every vehicle that we have out there on the market nowadays. 12 volt coil, great for doing what we need to do. But so when I go from my ignition point and I turn my key from the run, I go to the crank state. This capacitor right here is 6800 microfarad. What it does, it creates just enough charge to hold this coil latched down for this crank stage of my ignition switch to make contact and then feed voltage both here going down to my relay as well as going to my starter to start the vehicle. Now because the voltage is coming this way through the diode and down, it lets it latch down that relay, or keep the relay latched rather. But yet when I'm in just my run state, the voltage comes this way but it can't come back. So anybody that knows anything about diodes knows that they let you feed voltage one way but not another. So that's how I'm basically able to latch this circuit down, keep it latched down. Now mind you, depending on the resistance of your coil on your relay, you may have to go up or you may have to go down in your microfarads of your capacitor, because this thing's only going to hold so much charge, and the resistance is what's causing this charge to bleed off, and it bleeds it off at a delayed state. Now if I don't have enough capacitance, then I'm not going to have enough charge, which would result in a slighter bit of time or less time rather that this thing is actually engaged. So I safely go up. 6,800 microfarad is a pretty good assumption as far as where it needs to be, and I'll show you here in a second with a mocked up version of this that you can see where it actually latches down and holds that relay down for a minute. But it's stupid simple, easy to wire. You can put them in place, and all you got to do is have one feed from your accessory ignition. You know, it could be any accessory wire you have in your fuse box that comes on when the key comes on. That can feed your ECU. And then when you go to crank your vehicle, of course you have to have a line that's coming from that crank circuit into the relay as well. But here in a minute I'll show you how that's easy to wire, and this basically solves the whole issue of not having a constant voltage when you're trying to crank your vehicle. And you have, you know, back with our old analog style gauges and stuff like that, and the way the vehicles used to be wired and stuff, that wasn't, you know, that wasn't an issue. But now that you've got electronics and digital circuitry in these ECUs and these PCMs, they've got to have a constant 12 volts, and they need to have it from the point in which you get ready to start the vehicle through the point of trying to start the vehicle to the point of actually starting the vehicle. So this will basically take care of that for you. I think in all you can get everything on Amazon for less than 15 bucks. I think it's a great workaround. Now some will say, you know, that you're doubling up voltage on this line right here. Well, your circuit's all got a common ground. It's going to be the same voltage. Anybody that has ever stacked batteries, you know if you stack batteries in parallel, then voltage stays the same, but the current doubles. If you run them in parallel, then of course your voltage doubles and your current goes in half. So that's not a problem. And the issue of safety, this thing does not latch it down for, you know, an extended amount of time, just long enough for that contact to go from the run state to the crank state. So it's not like you're going to have a problem with, you know, the motor not wanting to die or not be able to kill it, or, you know, if you have a fire you can't get this thing to shut off. I mean, that's not the case. So let me mock this up real quick and I'll show you what I'm talking about, and see if this might be able to help one of you guys. Alright, so as crude as this may appear, it's actually, I think it'll serve the purpose to show you what exactly I'm trying to do here. Basically we got an LED that's going to indicate basically your circuit that you'd be activating whenever you go to the run state, and then that'll show you how it still stays engaged when you go from the run to the crank and then back to the run. Basically I've just wired up a little switch right here. It's kind of hard to see, but got a little toggle switch right here. Basically, if you look at my relay the way I did it, I just kind of hot glued the capacitor to it and got my diode line and everything right there. And of course you got to know which side the anode and cathode is on your diode, but if you just remember that the line goes to the relay on your diode, then you'll be going in the right direction. So basically red would indicate like it's the run circuit, yellow would indicate that's the crank circuit. Basically if I wanted to show that I go to the run state, then when I do that, relay kicks on. Of course I'm holding it, so it's going to stay on as long as I'm holding it. But just as soon as I let it off, see, it takes about a second and a half to disengage. So that's just enough time for that switch to go from the run state to be switched over to the crank state, assuming you're going in a smooth motion and you're not going to stop or anything like that. If you stop, then yeah, the relay's going to drop off. But just as soon as you hit it with the crank, then it's going to kick back on. The goal is to go from one motion to the next, which would be from the run state to the crank state without a pause, and that way you've got just enough delay on the circuit to keep the contacts closed on that relay. If you want anything longer than that, if you're slow at starting it, whatever, then of course you can increase the microfarad on your capacitor, and then that would give you more duration and time with your delay off, or your delay on break feature with the relay. But anyways, basically if I was to go from, say, the run state, which would be over here, to the crank state, which would be over here, you'll see that there is no actual lapse in conductivity of the circuit, so that basically your circuit would never lose its 12 volt feed. So I'm going to go from a run state, switch over to the crank state. See, I never lost anything. I can let off, circuit dies. So again, I go to the run state, it's on, I switch my key from the run to the crank, circuit stays on. I never lose anything because that relay is being latched down with that capacitor. As soon as I let off, it dies off again. If I just go to run and let off of it, it's going to die off. So it's quick enough to be safe and long enough to be efficient. So hopefully this this helps somebody. I mean, I know that there's you can buy time delay relays all day long on Amazon. They're about 45 bucks. They run up to 100 bucks for some of them. They do the same thing, just a poor man's way of doing it if you want to go that route. Again, I can put the link on the videos for the capacitor, the relay, and the diode that I use. As you've seen in the schematic, the diode is a 1N5408, I believe, and then the capacitor was a 6800 microfarad. Relays 12 volt coil. Pretty straightforward. If you have any questions, shoot me a comment and I'll try to explain it to you or answer your questions. But this definitely works. I've been using it for years. It's never let me down. Anytime you got to have a constant 12 volt through that crank cycle, if your automobile doesn't give you that, this is a surefire way to get it. Thanks, guys.